Okay, so this is the outline of chapter 21 about the Coulomb's law. So the outline is also very simple. So the first title is the Coulomb's law itself, and then the second and the third is about the charges quantized and then charges conserved. OK， 就是电荷是量子化的啊，就是一颗一颗的，你不可能切成半颗哦，就讲完了。And then charges conserved 就是电子是守恒的啊，你不能创造一个电子，不能够就是电荷守恒嘛，就是不能创造、不能湮灭一个电子啊，也讲完了啊。So this chapter is really easy, just as what I mentioned. Okay, so this is the first slide. Okay, so the title is Magic question mark. Okay, so here you can see there are two figures. So let's take a look at the top figures. So it said the two grass rods were each robbed with a steel cloth, and one was suspended by thread. One was suspended by thread. OK， 所以这个意思是有一根玻璃的棒子啊，你悬挂着它啊，然后另外还有一根啊，你是拿着，然后你用那个湿的布啊，但那个材料你不需要记了啊，不会考这个东西，这个只是一个引子而已。OK，so if you try to use a steel rod to rob one of the grass. And then you put this close to another, this floating, okay, somehow like floating, it's hanging here. Actually, it is free to rotate. And then after you put this grass rod after rock close to this one, they will repel each other. 它们会互相排斥。那其实最近天气很干燥，大家应该都很有感觉的话，就是你碰一个什么金属的东西就会被电，就是有时候前阵子啊，有一天被电3次，因为我自己有开车，然后一下车一关门啪就电一次，所以后来的话我是用手就是衣袖去这样先碰，就感觉它啪一声，然后再去关门。就还好一些，就隔着衣服去包的话会好一些。Okay, so this is the phenomenon. Okay, so you try to absorb it. Actually, based on your high school physics knowledge or even chemistry knowledge, you should have known what is happening here. Okay, so here, the second one is we try to have a plastic rod. This one, the green one, is a plastic rod, and then you rub it with fur. Okay, just similarly, you don't need to remember the material. Okay, so here we try to rub this plastic, and then you try to bring this close to the hanging grass rod. Okay, so here it says when brought close to the grass rod, the rod attract each other. Okay, so here the difference is if here we have two grass rods. They will repel, and then here, if one is glass, one is plastic, okay, they will attract each other. So the title here is that whether it is magic, okay, of course it's not. It is a physics. Physics can be explained, okay, and then of course the physician have come up with a theory to really explain this phenomenon. Okay, so what they think about is here we should have something called the electric charge. 就是有一些叫电荷的东西。Okay, so here if we have two charge rods of the same size repel each other. Okay, so if we have two grass rods. Okay, after rubbing the gas, okay, so it will have positive charge. It will have positive charge, and then here it will also have positive charge. So they have the same polarity, and then they will repel each other. 那为什么它是正电荷的话，就是它跟化学有关。化学的话我就不会。 Okay, and then for the bottom one, okay, it says the two charge rods are opposite sign, and that they will attract each other. So this one, this glass rod still have a positive charge, but after you you use a fur to rub this plastic rod, it will have negative charge. So they have a opposite charge, they will attract each other. So plus sign indicate a positive net charge, and then minus sign indicate a negative charge. So this is really easy. Even primary students should know this, should be able to understand this. Okay. Okay. So here is a highlight. It says the particles with the same sign of electric charge repel each other, and then particles with opposite signs attract each other 就是小学生都会的嘛，就是同性相吸嘛，同性相斥嘛，异性相吸嘛 ，OK， 我都Okay, so this is just a simple phenomenon. They just try to introduce a concept called electric charge to really explain that phenomenon. And actually, in the practical world, we have some material. If we try to classify it due to their conductivity, so we have these four main materials. Okay, so actually in primary school you should have known these two, and then in high school you should have heard about this semiconductor, and maybe you should maybe you have already heard about the superconductors also. Okay, so just talk about it one by one. So the first one is conductor 导体 ，OK， 所以小学生就会了嘛。Okay, so conductor are materials in which a significant number of electrons are free to move. Example include metals 就是在周期表就是那个元素周期表的左边的那一些大部分都是金属嘛。那所以它的一个特征是这个叫做有自由电子有自由电子，就是这个导体的特征OK, so it has a significant number of electrons are free to move. 绝缘体的话，它还是有自由电子，但是很少，少到可以忽略，所以这个 significant 也是一个重要的字Okay, so the second material, the charged particle in non-conductor 非导体或者叫做绝缘体 insulators are not free to move. Example include rubber, plastic, glass 就是一些元素周期表右手边的是一些绝缘体嘛，或者是一些有机物嘛 ，rubber 是有机物 ，plastic 有机物嘛 ，glass 也是有机物，很多有机物都是没有自由电子的嘛，或者是元素周期表右面嘛，很多那种什么惰性气体什么的，这些都是或者一些右手边有一些固体也是碳某一些碳是不能导电的嘛，那就 insulator。Okay, and then the third type is called the semiconductor 半导体就是在周期表中间接近4A 左右的元素有一些3轴5轴也不一定Semiconductor are material that are intermediate between conductor and insulator. Example include silicon and germanium. So you should be familiar with silicon. This word. Germanium may be not so familiar. Also an element on the table in computer chips. 那半导体的话，就是怎么说？高中化学会听过，它也不会讲很多。为什么？因为它很难的，就是如果是 ECE 的话，它会有很多课会讲这个 semiconductor 的 device 怎么去算，可能就是它是一些所谓的非线性的一些元件刚才讲到So just now we mentioned 3 circuit element, three fundamental circuit element is called the RLC, just as what I mentioned. The resistor, the inductor, and the capacitor, they are quite linear, so it is easy to do hand calculation. But for semiconductor, their characteristics are quite non-linear， 就是有一些二次啊，什么 exponential 啊的一些，就比如说二极体啊，你们可能会有听过的 diode 啊 ，diode is a type of a semiconductor device, and then also for chips 啊 we generally use the MOS 啊，不是摩斯汉堡，是那个metal oxide semiconductor 啊，就是金属氧化半导体啊。它当然会有 PMOS 有 NMOS 有 P 型的正的 P positive 有 negative 啊，有正的有负的，那它两种加起来可以做成一些叫做 CMOS complementary metal oxide semiconductor， 就是做一些逻辑电路的，就比如说你那个电脑你开机你要进那个 BIOS 的时候，你可能会看过这个字，啊 CMOS 就是一些用来做digital 的 logic circuit 的啊，就是一些做一些数字的逻辑电路啊，就会用上这个 CMOS 啊，当然也可以做一些模拟的电路啊，那我们实验室做蛮多那个模拟电路。OK， 所以 semiconductor 就是说你高中会听过，但是他也不会讲，因为他数学很难，所以真的是读那个 ECE 啊，或者是 Double E 这种科系的话，才会有课读到啊。而且对啊，所以也可能读很多个学期，读很多学期，有什么电子学呀、什么电子学也修几个学期啊这样的。And then the final one is called the superconductor 啊，超导体啊，超导体就更，当然就是你看一些科技新闻的话，你可能会听过啊，但是这个又是更玄的东西，就是超导体的话，就是说它跟化学比较有关系，它跟化学，因为你要找一些物质的话，它是 perfect conductor 啊。That are perfect conductor. Superconductor are material that are perfect conductor. What does it mean? It means that its internal resistance is perfectly zero. 就是它没有任何的电阻的没有电阻的。因为有电阻的话，你高中学过嘛 ？B equals IR 嘛。那你有电流有电阻的话，你就会有电压降那就会有 P equals I square R， 就会有能量的损耗，或者是有功率的损耗它没有superconductor 是没有的，这个是 R 等于0的，就是没有任何的电阻，是一个 perfect 的 conductor 但是它的条件的话，就是需要很低的温度，就一开始发现的时候是需要低到接近绝对0度或者是绝对温度1-2度或者是几度这样需要用一些什么液态氦才能够产生那么低的温度当然随着那个发展的话，就是他们找一些物质的话，尝试比较高温就可以达到的。那前2年的话有一个提出说室温的超导体，那后来发现它是骗人的它是骗人的OK， 所以就是说，后来很多人都重复它的物质，但是发现是做不出来它原来的那个结果的。OK， so allowing charge to move without any hindrance 就是 perfect conductor 的意思那所以只是稍微提一下有这4种物质而已其实我们主要讲的还是前面2类了Okay, so here we also talk about the charged particles. So here it says the property of conductor and insulator are due to structure in electrical nature of atoms. 就是跟原子的那个结构有关的。Atoms consist of positively charged protons negatively charged electrons and electrically neutral neutrons 啊，就是有带正电的那个质子嘛，有带负电的电子，也有带中性的那个中子嘛，就是高中化学就学过。So the protons and neutrons are packed tightly together in the central nucleus and do not move 啊，就是高中学过嘛，原子核的话就是有一些的中子，有一些的有一些质子，有一些中子，然后外面有一些电子在外面动的。OK， 就大概想象那个原子模型长这样，但有什么轨道的，那我已经忘记了。Okay, so here we have a central nucleus and do not move. So when atoms of an inductor like copper come together to form the solid, some of their outermost and so most loosely held electrons become free, wander about within the solid 啊，就是当那些什么导体的元素的固体啊，那外层的那些电子的话就是自由移动，那核带正电的话就不能动啊。Okay, leaving behind the positively charged atoms, we call them mobile electrons, conduction electrons. There are few free electrons in non-conductor. 就是把前面那两句话再讲一遍，再讲一遍。Okay, so here we talk about the induced charge 啊 ，induced charge 就是这个叫做感应的电荷啊 ，induced charge 感应电荷 induced charge. So a neutral copper rod is electrically isolated from its surrounding by being suspended on a non-conducting thread. Either end of the copper rod will attract by the charge rod. Here, conduction electrons in the copper rod are repelled to the far end of that rod by the negative charge of the plastic rod. Okay, so here, too many words, so we can just take a look at this figure. So this figure have another configuration. So here we have a plastic rod. And this one is a copper rod. It's a copper rod. So copper is a kind of a conductor. So it says originally this copper is neutral. Is electrically neutral. And then you try to rob this plastic rod by the fur. Okay, so it has some negative charge. And then if you try to place this plastic rod close to this neutral copper rod, then the positive electron will be repelled by this plastic rod. By the negative charge of this on this plastic rod. Okay, and then actually this negative charge cannot go away. Okay, it still remain on the copper rod. So it means that on the whole copper rod, the total charge is still zero. Okay. So the only thing is that the negative charge can go as far as it could from this plastic rod. So the negative charge go to the right hand side. So it remains the positive nuclear on the left side. Okay. So even though this is a neutral copper rod, we will have the left hand side to be positive charge and then the right hand side to be negative charge. And in such a way, this positive charge part and then this negative charge part will attract each other. Okay, so this is something like that. Then that negative charge attract the remaining positive charge on the near end of the copper rod, rotating the copper rod to bring that near and closer to the plastic rod. 所以这个就是感应的电荷。那感应的电荷只会出现在导体。我们就不会假设一个 绝缘体的话有这种感应电荷，因为它的电子是不自由的，它不自由的，它怎么附在上面的话，我通常题目上面就是说它怎么附一些电荷在上面，正的也好，负的也好，附在上面之后它就不能动了。但是导体的话，它就有空间可以动，虽然它要保持着那个电荷不变，总的电荷不变。就是说，它有一些正的，有一些负的，但是加起来还是要等于零啊，还是要等于零。Okay, so here we have a formula about the charge. Although this equation is is not a very good one for the definition of the charge, because usually if you try to define charge, Q should be something like Q equals to something else. But here we have a derivative of the Q with respect to time equals the current. Okay, so it's more like a definition of the current rather than the charge. But it is already the simplest equation to mention about the charge. Okay, of course you can just take the integration on both sides, and then finally it becomes something like that. Q equals integration of I dt, something like this, and then something like this across a So it will be something like that. But here you just make everything simple. So we only have this the derivative of the charge. Derivative of the charge is the current. Is the current. 就是电子的流动，就是电流嘛。Okay, and then for the physics class, or even for other engineering class, SI unit is very, very, very important. Very, very important. Okay, 就是这个非常的重要，所以讲了3次啊。那在考试的话，就是这个 unit 的话，在答案的 unit 的话，每一个算1分啊，写错的话会扣1分。无论那个题目多少分也好，就是反正写错答案的那个 SI unit 就会扣1分啊。所以有一些可能要稍微记一下，但是有一些的话其实是可以推算出来的。就比如说我知道这个 I 电流的单位电流的 SI unit 是安培A， 那这个是 charge 是 coulomb。那这个是时间这个是时间。其实的话，你就会知道说 A 就等于1个 coulomb 除以1个秒1个秒，大概是这样的一个，或者是这个你可以移过去，就会变成这样所以 so first what you need to remember is that the SI unit of the charge is coulomb C. Okay, so it also says that coulomb means a charge that 1 ampere current flow for 1 second. Okay. So this is the definition of a charge. And then here we try to talk about what is the Coulomb's law. The Coulomb's law. So the Coulomb's law describes the electrostatic force. Electrostatic force 中文叫做静电力嘛静电力Okay, or electric force between two charged particles. Between two charged particles. So if the particle have charge Q1 and Q2 are separated by distance r and are at rest.所以这个是一个很重要的一个假设很重要的假设 are at rest are very important。就是说，你要假设那些电荷是静止的，那你算那个力，在那一个瞬间是有效的，是对的因为它一开始是静止的，然后它有力， 然后你学过那个 Newton second law of motion 嘛？那它就会有那个 F equals ma 嘛，它就会有加速度，它就会开始动啊。那它在下一个瞬间它就开始移动了，所以那个力已经是改变了啊，已经是改变了。所以为什么这个叫做 electrostatic 静电学的意思是，我一开始是假设它不动，然后这个力只有在那一个瞬间是对的。Okay, relative to each other, and then the magnitude of the force acting on each due to other is given by this equation. Okay, so I think you should have learned this Coulomb's law in high school. So just let's take a look at it. So maybe this one is called a vector form, 就是一个向量的形式。If we would like to write it in the scalar form, it would be something like F equals 1 over 4 pi epsilon naught times Q1, Q2 over R squared. Okay, so just ignore this vector sign, and then this R hat is another unit vector. Okay, so first let me try to introduce some of the constant. So this one, epsilon naught is 8.85 times 10 to the negative 12 with this SI unit. Okay, of course this constant you don't need to remember, although I already remember because I need to repeat this 8.85 times 10 to the negative 12 again and again in the course. So actually I will remember this 8.85 times 10 to the negative 12, this 8.99 times 10 to the 9th power. Okay, but actually I will provide this constant to you during the quiz or final or exam. Okay, so this epsilon naught is called the permittivity constant. Permittivity constant. 中文叫做电导率。电导率。电导率。Okay, so it's a very important constant for the electrostatics. Later in chapter 28, you will learn another one called the mu naught, called the permeability constant. Permeability constant. These two constants are really, really important. Okay. Actually, this one is something like 4 pi times 10 to negative 7. 4 pi times 10 to negative 7. Yeah. Okay, and actually, this whole thing, 1 over 4 pi epsilon naught, will usually appear together. So we also define this 1 over 4 pi epsilon naught to be a constant called K. Here it just call it the electrostatic constant or the Coulomb constant. I don't remember the name. So I only remember K is something like 8.99 times 10 to the 9th power with this SI unit, which is equal to 1 over 4 pi epsilon naught. And usually they will appear together. 就是绝大部分时间会一起，偶尔它会单独出现，偶尔这个 epsilon naught 会单独出现，就是很少机会会去单独出现的，就是20次有1次会单独出现，大概是这个比例。绝大部分时间的话，它就会一起。所以的话，你可以写等于 k 乘以 q1 q2 over r 平方就可以，或者是这里我就这个就用 k 就好。但是它一开始这个式子的话，它就写完整1除以4 pi epsilon naught. Okay, so this is k, and then k is this one. Okay, so of course you already know how to use it, but let me try to mention about the vector form here. Okay, so here we have this one called the unit vector. the unit vector. Actually, this unit vector is in the spherical coordinate， 在球坐标里面的在球坐标里面的。OK， 因为平常的话，你们学的是那个直角坐标系的话，它叫做笛卡尔坐标 （Cartesian coordinate） 嘛 ，Cartesian coordinate 那就是 x hat 这本书不叫 x hat， 这本书叫做 I hat I hat。J hat K hat， 通常没有那一点，就 I J K 是对那个直角坐标系的。那这个 R 的话，通常是用在这个球坐标的。So how do we define this R hat? Okay, so let's take a look at it. So here we have two charge Q1, Q2 here. So Q1 on the right side, Q2 on the left side. Okay, so here we will try to mention about the force acting on Q1 due to the charge Q2. Okay, so here we will try to have the R axis. R axis is pointing from the Q2 to the Q1. Okay, and then R hat is actually the unit vector. So this is actually the unit vector pointing to the right side for Q1. For Q1, this one is for Q1. This one is for Q1. Okay, so the direction is starting from Q2 pointing towards Q1. Okay, so in this figure is from bottom left to top right. Okay, and in that case, our head is pointing to the right side. It's pointing to the right side, and yeah. And if Q1 and Q2 are all positive, Q1 and Q2 are all positive, so this is positive, this constant is also positive, R squared is also positive. So this big thing is a positive value. So which means that this F vector will have the same direction as this R hat. Okay, so in this case, we will have F also pointing to the right hand side. Okay, just as here, plus and plus, these two are positive charge. Okay, so one thing need to mention is that if we want to describe the force acting on Q2, here the R axis will be something like that. This R axis is for Q2. So this R axis will be from right hand side, from Q1 point towards Q2. Okay. So in that case, for Q2, the R hat is pointing to the left side, and then this R hat will have a magnitude of 1， 就是它的长度是1所以它叫做 unit vector。但是对于 Q1、Q2 来说，这个 R hat 是不同方向的，这个 R 轴也是不同方向。所以如果你这么看的话，Q1、Q2 也是正值，那带进去的话，正数，那所以 F 跟 R hat 是同个方向，所以作用在 Q2 的这个 F， 也是跟这个 R hat 同方向你就会看到这个 F 跟这个 F 指着反方向这个 R hat 跟这个 R hat 指着反方向，因为这一套是对 R1 是对 Q1 来说的这一套是对 Q2 来说的，那他们就可以 share 同一个式子。Okay, and then the punchline for this one is that if we have other combination, so the charge can be positive charge or negative charge. So we altogether have 4 combination. Okay, plus, minus, plus, minus. Okay, so for the second case, okay, so this is still the first case. So just as one we mentioned, I don't try to repeat. And then for the second case, if both are negative, okay, so of course these R hat for the right charge is pointing to the right side, and then the out-head for the left charge is pointing to the left side, out-head, and then out-head for this one, should be out-head, okay, out-head. Yeah, so the blue out-head pointing to the right side for the right charge, and then for the out-head is pointing to the left side for the left charge. Okay, so here let's take a look at the second case. If both are negative charge, okay, so negative times negative will be positive, and then positive, positive. So this whole thing is positive for the case B, okay? So which means that the F will have the same direction. The F will have the same direction as the out-head, okay? And then for the third case, plus negative, this is positive, this is negative. Okay, so Q1 is positive, Q2 is negative. So they multiply to be a negative number, and then this positive, positive. So this whole thing is negative for case C. So in this case, F vector will have the opposite direction as the unit vector. Okay, so in this case, F hat points to the left side for the right charge, and then the F points to the right side for the left charge. Okay, so for the fourth case, if this is negative, this is positive, it will simply like this. Okay, you can check it by yourself. So negative, positive, and then this will be negative, and then the F and R hat will point to the opposite direction. Okay, so this is the beauty of this vector form. If you can define the axis correctly, and then you substitute the polarity of the charge correctly, and then based on this vector form, you will already know the direction of the F with respect to the out-head. 所以很多时候其实有两种方式可以去定那些力的方向的，就是一个就是靠你那个什么同性相斥，异性相吸的那一句话，就是我知道它同性，它就会排斥，它就会排斥。那然后它如果异性的话，它就会相吸嘛，就是吸引嘛。那不然的话，你如果能够定义那个式子，定义那个轴你这个凹轴的方向，你都很理解的话，然后你又把正确的正负号都带进去的话，你就会知道你就不需要透过那种想象去知道那个力的方向。所以怎么说？有时候看你喜欢用哪一种。但有些厉害的同学的话，你两种都用一用嘛。那如果两个都给你同样的结果的话，那就代表说你想的东西是对的。Okay, so the next part is about the multiple electrostatic force. Okay, so just now for this Coulomb's law, it just tells you that we have two charged particles. If we have more than two, what should we do? Okay, so if we have multiple electrostatic forces, okay, so it says if multiple electrostatic force act on a particle, so the net force is the vector sum, not scalar sum of the individual force. 那就是那个向量和，那高中物理就应该就学过这个什么叫做 vector sum 嘛。那就是说，现在说就是说，现在有 n 个带电的粒子，就比如说有 Q1 有 Q1 然后有 Q2、Q3 一路到 Qn 有很多个，我就不画是正还是负了，反正就是可以正可以负的。那每两个之间，它们就会有一个力，要不然吸引，要不然排斥嘛，就是看它们是电荷的是同性还是异性嘛。那所以的话就是比如说 Q2 就会有一个力比如说 F2 是这个方向的，Q3 就会有一个 F3 是这个方向的。 然后 Qn 也许就会有一个力是这个方向的。Okay, so there will, if there are n charged particles here, there will be n minus 1 forces acting on each of the charge. Okay, so if we need to calculate the net charge acting on Q1, we need to add all these n minus 1 forces together using the vector sum 那你就要分它的什么 x 方向 y 方向如果在同一个平面的话就只有 x 方向 y 方向如果是立体的话就有 x y z 方向那你就要分x 方向的分量全部加起来 y 方向的所有分量加起来那才是那个总的力的一个大小。Okay, so here we try to mention a shell theory. We don't try to prove it here. Actually, in chapter 24, chapter 23, we will use the Gauss law to really prove these shell theories. But here you just try to believe it is correct. Try to believe it is correct. Okay, so what does it mean? So here it says there are two shell theory for electrostatic force. 它这个 shell theory 有两个版本So for the shell theory number 1, it says the charged particle outside a shell with a charge uniformly distributed on its surface is attracted or repelled as if the shell's charge were concentrated as a particle at its center. 很长哦。那第二个 shell theory number 2, a charged particle inside a shell with charge uniformly distributed on its surface has no net force acting on it due to the shell. 很长，像那个绕口令。那什么意思 Okay, so let me try to elaborate it a bit. Okay, so for the first one, it says a charged particle outside a shell with a charge uniformly distributed on its surface is attracted, repelled as if the charge were concentrated. Okay, 所以第一个版本 shell theory number one is something like you have a shell. Of course, this is a 3D sphere, 就是一个3D 的球体啦。我这里只能够画一个圆形。And then it says if it has some charge uniformly distributed, uniform 这个字很重要，就是均匀的电荷分布。它可以是正的，可以是负的正跟负没关系，所以我先假设它是正的。So it has some positive charge, uniform distributed charge on the shell of this sphere. Okay, and then we assume the total charge here is capital Q, 就是它的总电荷量在这个球面上面是大 Q. And then if we assume we have another charge which is outside this sphere, has a charge amount of small q, okay? So whether it is positive or negative, or for explanation, I just assume this is a positive charge. This is a positive charge. And you can simply imagine that this positive charge and this positive charge sphere will attract each other. So how large is the force? Okay, it will be difficult to compute if you really need to calculate. But the shell theory tells you that if this charge distribution is uniform, you can just assume that all the charge are concentrated into the center. Okay, so it's just like all the charge are concentrated at the center. Okay, and then we assume this distance is, let's say, small r. Let's say this is small r, and then we have this small charge q. So the force acting on these two, for the bottom case, it is easy to calculate because this is two charge particle. Okay, so the force will be nothing but K times capital Q times small q times over R squared. So it's just nothing but the Coulomb's law. So in this case, we will say the force acting on this small charge Q and also acting on this sphere with a charge capital Q is also this F. This formula also apply for that one. This is what the shell theory number 1 tells you. Okay, so in Chinese, 就是中文的意思是说，如果你有一个球体，它有一些电荷是均匀分布的正的也好，负的也行然后如果你另外有一个电荷在这个球壳的外面你如果要算它们的力作用在它们身上是多大的话，你可以假设说所有电荷都是集中在它的球心，然后所有集中在这个球心的话，那你就可以把它看成是一个电荷。那两个电荷的话，你就可以用库伦定律。这个就是 shell theory number 1告诉你的。Okay, so this is shell theory number 1, and then for the shell theory number 2, a charged particle inside a shell with a charge uniform distributed on its surface has no net force acting on it due to the shell. Okay, 所以这个的话就比较简单。So for this case, suppose you still have a sphere with a uniform charge. Something like this. Okay, so here we still have the total amount of charge on the sphere is capital Q, and here if we assume you have a charge small q inside this sphere, okay, so the force acting on this charge and also the sphere will be 0. So there will be F equals 0. F equals 0 on this charge and on this sphere. Okay, so this is shell theory number 2. Shell theory number 2. 所以就分成2个 case。那这2个 case 的话，我们都有一个球壳，那球壳上面都有均匀分布的电荷均匀分布电荷，可以正可以负的，我只是画正出来，负的也是一样的。那如果在外面的话，你就可以把所有的电荷当成在那个球心的位置，然后去算这个库仑力，或者是算这个静电力。那如果是那个电荷在这个球壳的里面的话，那它就没有力作用在它们上面。Okay, just as what I mentioned, I will not prove it recently. And then after learning the Gauss law in chapter 23, we will be able to prove it. 就是我们是需要利用这个高斯定律才能够比较简单的去证明因为这个高斯定律的话，它背后藏了很多数学，我们就不需要理会那些数学，然后就利用这个高斯定律就可以证明。如果你真的要用一个微积分的方式去证明的话，那就很复杂，因为就比如说你有一个球壳嘛，那你就要把球壳切成很多很多小块，那每一个小块你就把它当成一个电荷来处理，因为它不能够很简单的看的话，就是说，比如说这个部分到这里的距离，跟比如说这个部分到这个的距离就不一样，然后每一个力的角度都不一样，所以你就要算很多的这样的小的力。算完之后加起来，那这个加起来的话，其实就是一个积分。这个积分非常的难算，非常的难算。所以的话，就是说，我们不会尝试用微积分去证明这个 shell theory， 而是偷鸡，我们就会用这个高斯定律，它背后藏了的数学我们就不用管它，然后它就可以很简单的去证明这个 shell theory number 1 and shell theory number 2是正确的。但是这个会在 Chapter 23这23章的时候才去说明，OK， Yeah, so maybe let me stop here today and then we will have class on Thursday.